Today on Xeno Dilly-Down, here we have in for repair an ArtFox show laser, and its issue is that it has very weak blue laser output. We're only getting 10% of the blue laser output that we should be getting, so if we put it on something like white, we get a very yellowish looking output as a result of that. In this case, it could be one out of two issues. Either it could be a bad laser diode driver, or a pair of bad blue laser diodes. Let's take a look at the back and see what we have for inputs and outputs. And as you can see, it looks fairly standard. We have the DMX in and out, the power, a couple of knobs here for things like microphone sensitivity, and the image pattern size, and then the ILDA input and output. Now, what we're missing is things like the key switch interlock and the external interlock for remote shutoff. So right off the bat, we can already tell that this thing is not FDA compliant, and is therefore illegal to use in a public venue. Another interesting thing to note is the ILDA input and output labels are reversed. So in order to get a signal going into the laser, we plug it into the output. Due to the poor quality of this laser, I would say that ArtFox tend to have gone with disposability over serviceability, and therefore we're going to give it the special name of FartBox instead. Let's get inside and see about repairing it. Alright, I've opened up the FartBox laser, and using some flying camera action, we can see its construction in a bit more detail. Let's start with the risers here. They go from the bottom of the laser case and hold the optical table in position. And they weren't long enough, so they used a couple of nuts to give it a little bit more height. On this side, you can see that they used Allen screws to hold the optical table to those risers. However, on the other side, they decided to use Phillips instead. Yeah, that's consistency right there. The DMX goes to absolutely nowhere, and given that those wires are cut, it's probably not a new part, but a part that was pulled off from another lighting product. Over here, you can see that the microphone isn't connected to anything at all, and neither is the potentiometer that's underneath it. And if you look closely, you can see a portion of electrostatic bag material that was cut and placed between that potentiometer and the other one to the right, providing a little bit of electrical isolation. And if you think the quality stops there, just wait until we get inside of the laser head for diagnostics and repair. Let's get inside of the laser head and get a measurement on the amount of current that the laser driver is putting out. And given that it looks like it's 2 watts of blue output between 2 laser diodes, probably going to be a pair of M140s, so I'm going to use the multimeter and check to see if we're getting at least an amp from the laser driver itself. Let's open up the laser head. Oh man, this is what you get when you cross a laser with a toaster strudel. These are the blue laser diodes right here. And it looks like the red wire is going to them. So I think I'll be able to just pull this up and put the multimeter in right there. So let's go ahead and undo that. That can just sit there for the time being. Alright, now to turn on the laser and get blue output. Alright, so far we're getting about half an amp. Turn it up all the way and see what we get. Oh yeah, we're getting just the right power. 1.35 usually what I see on the M140s. Let's figure out what potentiometer now inside of the laser driver turns that down. So I have 3 potentiometers here. I believe that these are for color correction, and that one right here is for the main output power adjustment. So that's the one right here that I'll be adjusting. Let's see what we get. Oh yeah, that's current adjust. So I'm turning it counterclockwise. Alright, cool. Now we can get into installing the new laser diodes. So I'll turn off the laser unit and I'll disconnect the multimeter for the time being, and I'll pull out the laser block, which is this block right here. Looks like it's just held in by 2 screws. So, it should go pretty easy. Oh yeah, just 2 screws. Man, those little mirrors are a nightmare. They don't look fun at all. Why no adjustable mounts, ArtFox? Why no adjustable mounts? Gonna unplug the laser completely and get ready to see about removing those laser diodes. Alright, well, it looks like they're just held in from the back, so they should unscrew pretty easily. Just gotta get something in there that's long enough. Need more torque than that. Man, those are deep. I may have to make a custom tool for that. Right. Well, that's fun. Let's do that. Here's the custom tool that I made, and it just has two little notches on the top. And that goes into the two notches on this piece. The hollow area goes over the laser diode wires, and these two notches go into little holes, so that way you can pull this piece out. However, it gets a little bit more complicated than that. We have evidence now that ArtFox definitely does not want this to be user serviceable at all. And I'll show you about that in just a second. So, I'm going to do the same thing. I'm going to extract the other blue laser diode. Hey, this one's at least clean. I'll show you the first one that I pulled out. So the one on the right actually has some gunk on the top of it, and the one on the left is the one that I just pulled out. But let me show you what I mean by they did not want you to service them. So here's the first insert holder that I pulled out for the first laser diode, and here's the other one. Now you might notice that there's 3 holes in the one on the right, and that's because I actually had to drill another hole in so I could use the tool. They actually have staggered holes on half of them. So for example, the second one had a hole that was slightly off center with this one, so I had to drill that one with a very small drill bit, and they definitely did this on purpose. Let's take a look at the laser block, and we can see this on every other laser diode. So right there, that one's evenly spaced in the middle. That's a staggered one right there. That one's a staggered one right there. And that one's spaced in the middle again. So yeah. What wonderful ideas people have. Too bad there's nobody on YouTube doing laser repairs. Should call out this kind of crap. Let's get new laser diodes installed. The first step in installing a new laser diode in this particular laser block is to solder on 2 shorter wires directly onto the laser diode. And in the case of the FartBox laser, they decided to use the yellow for the negative and the blue for the positive. So I'll be doing the same thing, using the red for the negative and the blue for the positive. Let's go ahead and solder those wires on carefully. Alright, that looks pretty good. And the reason why I have those joined at the top is to prevent any kind of electrostatic discharge during handling and installation. Because a laser diode is pretty sensitive, I tend to use the soldering iron just to heat shrink those wires on instead of using the heat gun. Alright, that looks pretty good. I'd say it's ready to install. Due to the way that the optical assembly is, the laser diodes have to put a rectangle that's sideways. So orientation of the laser diode is important. This is why I have the markings here. So 1, 2, 3, showing me that the unused pin is facing downwards. Keeping that in mind, I'm going to take the laser diode and the insert that holds it, and I'm going to place that into the laser diode mount. And then using a small screwdriver, I'm going to insert it most of the way. At one point it's going to feel like it's pretty tight. I'm going to ease back on that, and then adjust the position of the laser diode. And I'm going to take these wires and fold them over inside like this, so that way we can get the tool fit around those wires. And mind you, the tool is going to twist the laser diode a little bit, so you might have to do this process a couple of times just to get the laser diode in the correct orientation. Yeah, that'll do. Hopefully now just a few more things to do, which is to set the laser diode current and check the optical alignment. I've already soldered on the negative wire to the laser diodes, and I've put them in series, and I'm going to set it for about 1.2 amps. So let's solder the multimeter up in series with those laser diodes again, and then give the laser power. Okay, looks good. Let's turn on the laser. Plug it in. Turn it on. And calibrate current. Enable. Okay. And then bring up the brightness a little bit. And start setting the current for that. DC helps. Alright, bring up the brightness all the way. and see what we get. Looks like one laser diode may be bad. Hard to tell, but definitely looks like that this one isn't working. Bummer. I'm gonna have to pull that one out again. Nope. Yeah, we got output. Never mind. Oh, both lasers look to be working okay. Oh, that's much nicer than what we had before. Yeah, let's leave it there, and we have to redo the optical alignments a little bit, but should be good. After a few hours of working on those cheap bend-to-align optics inside of the laser head, everything is now working as it should be, and it's time to put the laser back together. But before I do that, I want to point out that there's no shutter inside of the laser, nor is there a scan fail system, and that just shows you how much they prioritize safety inside of these lasers. This is by far one of the worst lasers that I've had to work on. Its build quality is absolutely terrible. There are no safety features inside of it at all, and they deliberately made servicing this harder than it needs to be. So my recommendation is don't buy a laser from ArtFox. They're really terrible devices. I have a couple of words of advice for ArtFox. Affix your feces, and I don't mean this way. Seriously, you guys can do better. Now you might be wondering how to check the laser diode in your show laser or other laser related product to see whether it's good or not, and I'm going to quickly show you how to do that. Here I have an M140 that's good, and it's connected up to a laser driver, and if I turn it on, we get a very nice laser output. To check the beam profile in a little bit more detail, I'm going to use this lens to expand the output, and if we give it a little bit more distance, we can see that we get a nice rectangle, which is what you should be getting from your laser. I'm going to hook up the bad one from the FartBox laser, and we can see its beam profile a little bit better too. So right away we can see that it's a lot dimmer. So to see that better, I am going to turn off the lights. I'm going to do the same thing and put the lens in front of it, and we can see its profile. So what we get is a circular output that has a bunch of dark spots on it, and this is a symptom of catastrophic optical damage. And if you see output like this, it is time to change your laser diode. Sometimes it can be difficult to get a lens like this inside of a laser head, and when that happens, I use a little mirror like this to simply reflect the beam out of the laser head, and I'll put the lens in front of the beam that's being reflected out to get a better view of the laser beam profile. Well, that's about it for this video. I hope you enjoyed, and as always, stay tuned for more.